Welcome to The Explainer. Today, we're unpacking a really groundbreaking paper published in May 2026 by researchers Tunde Kushimo, Bradley Holt, and Mohammed Talal. Now, the title's a bit of a mouthful: Program-Level Curriculum Analysis of U.S. Quantum Master's Degrees, Implications for Workforce Preparation. But hey, don't let that academic jargon fool you. What this research actually does is expose a massive, critical bottleneck in our tech future. We're talking about a giant gap between the quantum systems of tomorrow and the actual people needed to build them today.
Okay, let's dive into this, because the stakes here, they literally couldn't be higher. We all know the incredible, mind-bending potential of quantum computing, right? But this paper asks the absolute million-dollar question: who is actually going to build this stuff? Who is going to turn that crazy math on a whiteboard into the physical hardware humming in a server room? Because as it turns out, right now, we might not have the right people for the job.
Section 1. The Quantum Workforce Problem.
Listen, quantum technology, it's not just cool, theoretical science fiction anymore. It is a super pressing national issue. The researchers point out right out of the gate in their abstract that quantum technologies are increasingly recognized as a huge strategic priority for the United States. They break it down into three absolutely critical pillars: economic competitiveness, national security, and technological innovation. I mean, the country's global standing literally hinges on leading this technological revolution. If we fall behind in quantum, we fall behind in the global economy and in national defense. Having a workforce that can actually deliver on this promise is, well, it's absolutely essential.
The paper points out a massive, fundamental shift happening in the field right now. We are moving away from those fragile, one-off prototypes sitting in a university lab and moving toward stable, deployable technologies that real-world commercial industries can actually use. And you know, this shift puts the spotlight squarely on higher education. It begs the question, are universities actually aligned with what the industry desperately needs to make this a reality?
Section 2. Analyzing degree programs.
Let's move to and see how this builds. To figure out if higher education is actually up to the task, the authors essentially turned into academic detectives, and their methodology was just incredibly thorough. Step 1. They audited primary U.S. master's programs. Step 2. They systematically mapped out all the course offerings. And Step 3, they took those educational profiles and held them right up against industry-identified needs. Basically, the exact skills that recent workforce studies say companies are out there begging for.
And to do this right, the researchers didn't just look at these classes broadly. No, they mapped the course offerings across exactly 6 quantum-relevant skill categories. Just 6 specific buckets. By breaking it down like that, they were able to aggregate all this data and produce highly accurate program-level skill profiles. It's almost like they created a blueprint, you know? A blueprint of exactly what a student knows how to do the literal day they graduate from one of these master's programs.
Section 3. Expectation versus educational reality.
Okay, so here is the plot twist of the paper. They've found a shockingly stark disconnect between what the industry desperately needs and what universities are actually teaching. The findings show that universities have this massive, heavy emphasis on quantum theory, but the industry, they have a desperate need for applied technical skills. I love the architect versus construction worker analogy here. Our universities are doing a phenomenal job producing phenomenal theory architects, people who totally understand the crazy complex physics and mathematics of how a quantum computer should work. But the industry urgently needs the technical construction workers, the engineers and applied scientists who actually know how to build the cooling systems, program the lasers, and wire the deployable tech. Right now, we've got way too many architects and just not enough builders.
Now, what's really interesting about this slide is how clearly it shows that alignment matrix. In that first column, you've got strong alignment in quantum theory. Basically, everybody agrees on the physics. But look at the second column. That exposes the persistent gaps. The study found substantial, wild variability in how these programs teach technical skills, applied learning opportunities, and professional development. It's a huge inconsistency. You might go to one program and get tons of hands-on lab time, but actually, scratch that. At another program, you might just be buried in equations the whole time. That persistent gap is literally what is holding back workforce readiness.
Section 4. Bridging the skills gap.
Fortunately, the researchers don't just drop this bad news and run. They actually give us a concrete solution to these educational roadblocks. We have to actively address these gaps by improving workforce readiness right out of the gate and really integrating cross-disciplinary skills. That means physics students need to learn software engineering, and computer scientists gotta understand quantum mechanics. If you're a student watching this explainer right now, mastering those cross-disciplinary intersections is your literal map to getting hired and makes you exactly what the industry is looking for. And as citizens, this is how we ensure the U.S. stays technologically relevant on the world stage.
And this brilliantly illustrates how this research isn't just a critique, it's a real tool for higher education to adapt. To make all of this actionable, Kushimo, Holt, and Talal built what they call a scalable framework. It's basically a structured, adaptable method, a living diagnostic tool, really, that universities can use right now to continuously evaluate their quantum programs and constantly realign them with what the industry actually needs to stay relevant.
To really sum up the ultimate value of this paper, I want to read you a quote straight from their abstract. The authors state that this study, quote, provides evidence-based insights for curriculum design, workforce policy, and the continued development of the U.S. quantum ecosystem, end quote. And honestly, that is the whole shebang right there. The goal is aligning education with industry to take all this amazing theoretical potential and turn it into the actual classes, policies, and trained professionals we need to make the quantum ecosystem thrive.
So the theory is definitely there. The stakes for our economy and our security are absolutely immense. We know exactly what the industry needs, and thanks to this research, we finally have the framework to fix those educational gaps. But as this global tech race accelerates, it leaves us with one final urgent question to ponder. Are our universities truly ready to build the quantum workforce? Thanks so much for joining me for this explainer. Keep questioning, keep learning, and stay curious about the quantum future ahead of us.